Hello, you beautiful people. Let's basically do what we've been doing, but like in word problems. So same, rational number operations. We're dealing with decimals and fractions, multiplying, dividing, and adding, subtracting, all the things, and our integer rules. We're just going to look at real world contexts. So first example, let's look at Virgil. Virgil borrowed $800 from his grandparents to start a lawn mowing business. So he borrowed $800 from his grandparents. After mowing lawns for a month and paying his expenses, he was able to pay back his grandparents $188.56. So how much does Virgil still owe his grandparents? All right, so what do we understand from this? We know that he borrowed $800. And clearly when we borrow money, we owe that, right? So that's like negative, yeah? So we know that. And then he's paying back almost $200. So $188.56. We know that's positive because he's paying that back. And it's always positive when we get money back from someone that we let borrow money from, right? So the plan is we're going to add these two together. So I say put or add two values together. Right, because we have negative 800 plus the 188.56. So different signs, subtract, right? Same signs, add and keep, different signs, subtract. They're different signs. So I am going to put the 800 on top because that's my larger absolute value. Put the 188.56 on bottom. And I just know that my answer is going to be negative because I still owe money. And owing someone money, that's negative on my end because I don't have it. It's not mine. I owe it to someone else. So let's align our decimals, and I'm going to do a lot of borrowing here. So this guy becomes a 10, he becomes a 9, which borrows from this guy. He became a 9, which borrows from this guy, and then he becomes a 7. I do like to do all of my borrowing at the beginning just to make my life easier, right? So 10 minus 6 is 4, 9 minus 5 is 4, 9 minus 8 is 1, 9 minus 8 is 1, and 7 minus 1 is 6. Well, Virgil, my man, it looks like you still owe $611.44. Now, I'm writing that it's still owed, so I don't need to put the negative in there. So the negative just represents the fact that we owe it. So mathematically, the word owe becomes negative because we owe that to someone else. But the fact that I'm writing it out that he owed it, I don't also need to put the negative. So 611.44 is your final answer. Done. That's how much he still owes. Next, real world problem. A cell phone company charges Michael a late fee of $3.84 per day until the balance is paid. If Michael is 8 days late, how much of a late fee is he charged? Wow, okay, so Michael is charged a late fee of $3.84 per day. Well, that word per tells us to multiply. We know that. And so the balance is paid off. He is 8 days late. God, Michael, you really got to pay your stuff. We're trying to figure out how much of a late fee is he being charged. So what do we understand? We know that it's a fee of $3.84 per day. And we know that it is 8 days late. So my plan is, well, per means to multiply, or I can repeatedly add this 8 times, but I just feel like that is just a lot of work when I can just multiply. So let's multiply the 384 and the 8. Now, please tell me we know that this is negative, right? Because it's a fee. So I know my answer is going to be negative because that's how much we owe. That's how much he's being charged, right? So 4 times 8 is 32. Carry the 3. 8 times 8 is 64. Plus 3 is 67. Carry the 6. 3 times 8 is 24. Plus 6 is 30. The decimal goes twice in. Wow, holy smokes, Michael. You owe $30.72 just for not paying your stuff. Well, yeah, just for not paying your stuff. You really just got to, man, pay it. Anyway, that's your answer. But again, I'm not actually writing that it's negative 30.72 because I put the word charged on there. So he still owes it. Cool. Let's do 2 more examples and then we'll call it good. Because real world context, y'all. So Adalia bought 3 slices of pepperoni pizza, 2 slices of cheese pizza, and 3 fountain drinks. Wow, I really hope this isn't all for her. You know what? Shoot, even if it is, you go, girl. The sales tax was $1.61. Adalia paid with the $40 bill. Well, 220s, I'm assuming. How much change should Adalia receive? Okay. Yeah, there's a lot going on here. What do we understand? We understand that there's 3 pepperoni pizzas, well, slices, whatever. 2 cheese, 3 drinks. You know, it's probably for her and her friends because I can't imagine anybody can suck down 3 drinks. It just seems like a lot. There is sales tax that we also need to add in. And then she's paying the $40. And we're trying to figure out how much change. So, man, I'm going to be doing multiplying, adding, and subtracting, right? So I'm going to multiply / add to figure out what my total cost is of like all the things. Then subtract from 40, right, to figure out the change. That's a lot. Okay, let's get to it. So 3 slices of pepperoni. So I'm doing 3 times 375. 5 times 3 is 15, carry the 1. 7 times 3 is 21, plus 1 is 22. Carry the 2. 3 times 3 is 9, plus 2 is 11. All right, and then 2 cheese pizzas. That's $3.45 each, so I'm just doubling it. 5 times 2 is 10. 4 times 2 is 8, plus 1 is 9. 3 times 2 is 6. Okay, and then I've got 3 drinks. 5 times 3 is 15. 5 times 3 is 15, plus 1 is 16. 2 times 3 is 6, plus 1. Okay, now I'm going to add all these together, aligning my decimals. And the tax, right? Got to add in that tax because that's, you know, we got to pay our taxes. We live in that kind of society. So 5 plus 5 is 10, plus 1 is 11. 3 plus 9 is 12, plus 6 is 18, plus 6 is 24, bringing down my decimal. 2 plus 1 is 3, plus 6 is 9, plus 7 is 16, plus 1 is 17. Okay, so $27.41. And then I am subtracting that from 40. Okay, doing a lot of borrowing. All the borrowing. All right, so 10 minus 1 is 9. 9 minus 4 is 5. 9 minus 7 is 2. And 3 minus 2 is 1. So she should get back $12.59 from paying. Cool. Man, that was a lot. That was a lot. Okay, next one. The volleyball team is raising money for a new net and equipment. They need $842.36 to make this purchase and have received $300 in donations. Wow, that's lovely. The remaining amount will be equally divided, that's important, among the 4 different fundraisers throughout the summer. So how much money will each fundraiser need to raise in order to purchase a new net and equipment? All right, we understand that we need 842.36. We have 300. We are going to split equally, splits into 4 groups. The remaining right? Because that's how much is left over. All right, so my plan is to subtract and then divide. Subtract figure out how much is left, and then divide by 4, right? Oop, I don't know what that was. There we go. Okay. All right, so I'm subtracting how much they need versus how much we've already received. So 842.36 minus 300, that should be mental math, right? Okay, so I still need to raise $542.36, but the 4 different fundraisers we're going to split equally. Okay, my divisor is a whole number, so now I just need to just regularly divide how I'm used to. 4 can go into 5 one time. 4 can go into 14 3 times. 4 can go into 22 5 times. If I'm going too fast, you are more than welcome to pause. That's forever and always for all videos, forever. Y'all know this. You're on social media, you know how things go. 4 can go into 23 5 times. And then 4 can go into 36 9 times. 0. So, each fundraiser will raise $135.59 to meet their $842.36 thing. Cool. Yeah, I did go fast. That did happen. I did do that. If you have questions, clearly ask your teacher. It is literally our job.